All right, let's go ahead and just kick things off right away. First of all, welcome to the GameBench Performance Matters webinar series. My name is Eli Scheele. I'm a principal engineer at GameBench, based in Los Angeles. And if you don't know what GameBench is or who GameBench is GameBench is a game performance management company. We build tools and services for game studios, publishers, OEMs to test and ensure that their games are performing optimally on mobile devices. So today, our presentation is entitled How to Collect and Analyze Performance Data. And we're looking at the entire production life cycle of a mobile game, mobile title. So this is going from development all the way through production environments. And why is this important? Why do we care about this? And let's see if I can get here we go. Why this matters. And the reason this matters is poor game performance, poor, say, battery utilization or memory usage or overusing the CPU or GPU on a mobile device. It can cause a negative experience for players, which ultimately leads to reductions in user retention. So performance issues, their root causes tend to be pretty complex and can be complex and multifaceted. And they can be introduced at any point during the game's life cycle, and they can be discovered along that life cycle as well. So the earlier you can catch these issues, the less likely it is that they're going to make it into production, which would negatively affect your players. And there's a reduction in the amount of time and the cost to address these issues. One studio that we work with told us that for them, catching a bug in development costs them about $50. Catching it in production and then fixing it in production is around $5,000 in cost for them. And we're all game developers, or we work with game developers, and we want to make sure that our games make the best first impression on our users as we can. So this is why game performance really matters, and why it matters to collect it throughout the development lifecycle. So what am I talking about when I say development lifecycle? This is a very simplistic view of a game development lifecycle. It's pretty basic. We start on the top left in our development phase. This could be on a game that's already in production. Say we're adding a new feature or level or character, or some new thing to the game, or it could be a game from the ground up being built as a first release. So from development, we go over to our QA. This is typically either done in-house or sometimes with an external company that will play the game on a bunch of different devices. They'll be looking at a whole lot of different things, including performance or metrics around performance, but also things like gameplay usability, UX, smoke testing, localization testing. So there's a lot going on in the QA phase. Typically then, if there's any errors or issues performance-wise that are found in QA, they'll get pushed back to development. Or if there are gameplay issues, those also will get thrown back to development as well. Then from QA, typically, most studios will do a beta or a soft launch. This could be a restriction on the geographic area that a game is available in the Play stores. So you may want to just limit the release to the US or say the Philippines to collect some real world data from users out there. Sometimes it's an internal beta that is shared throughout a company. Either way, it's a more realistic environment. These are actual gamers that are, interested in playing your game, testing it, playing it, and again, providing feedback that can be fed back to the development team to improve the game. And then finally, we get into the production environment. This is the best time where, we put our game out there. It's on the Play Store. It's on the Apple App Store. Millions of people are downloading it, hopefully, and playing it, and they're having a great time. But any issues they run into, they don't really have that direct line back to the development team. There's less visibility on it. They can only kind of report their issues either by writing a review, which may have negative connotations and impact your actual placement inside of the Play Store and App Store, or it's more of a quiet signal where they just drop off. They stop playing your game, and then you've lost that customer acquisition cost. It's gone. So this is a very high-level overview of the game development lifecycle. I know studios have different flows depending on their size, titles, etc. But this is a pretty good encapsulation of what's happening. Now, one of the things I like to look at is the actionability. If we know there's an issue, who can do something about it? And it's this neat little pyramid, because at the production level, there's really nothing that can be done by the end user except write a review, have drop off as a user. There's no real actionability for them. Once you get to that beta soft launch phase, working our way backwards, there's more feedback, more detailed feedback that can be fed back to the development team prior to launch. Sometimes focus groups will be brought in on testing to see what their thoughts are. But again, it's a limited amount because you're dealing with real users, and they may say things like, oh, the game seemed really glitchy. And what does glitchy mean? I don't know. It could be a frame rate stutter. It could be that there's a networking issue that's causing load times to be longer. So the usability, the actionability of the feedback from the beta and soft launch from a technical perspective isn't always the greatest. And it's a little bit removed from the dev team anyway. Once you get into QA, you can typically get a little bit more actionability because these are testers that are familiar with their product usually, if they're in-house. They may know of previous issues or regressions that have occurred, and they can write better, more detailed bug reports for the dev team to actually work on. And then finally, we get to the development team, and they're the most actionable. They can do everything because they have access to the source code or art assets, and they know exactly, well, they should know exactly what's going on at every stage of the game. Now, when we compare this to what the actual gameplay environment looks like, the triangle stays the same, where there's a dearth of information at one level and a wide base at the bottom, but the labels flip. Typically, in a development environment, you have a developer at their desk. They may have a local device or two that they use for testing as they're implementing a feature or fixing an issue. Some studios, some of the more advanced studios, will have a small device farm that's local for them to, or a device cabinet that they can check devices out of and see how their games run against that. QA typically will have a much broader set of devices available to them, and they have a bit more of a remit in terms of they can do things like testing on real mobile networks. If you use a testing service that's in a particular region that you want to deploy to, you can actually get statistics on like network utilization from a network in Brazil, because a lot of testing services do have locations in other countries and other regions. Beta and soft launch, these are closer to the production environment in terms of the diversity of devices that you'll see, but because it's a beta or soft launch, it's a limited set, you're not going to get your full production environment. And of course, your production environment, you're going to get the whole gamut of devices that are out there today and networks. So you'll see things like older phones running more limited versions of, or older versions of Android OS or iOS that may experience different glitches and bugs and performance issues than the latest flagship phones. So that's really the conundrum that happens, is our availability of environmental information about the status of these games is the exact opposite of the ability to act on that information right now. So that's why collecting performance data throughout the development lifecycle helps to minimize this, helps to prevent issues from getting to production that take longer to fix in development. So let's just take a quick look at the development phase and what we can do there to monitor and ensure performance. So like I said before, this is at the developer or artist's desk. They have complete power and actionability. They know exactly what's going on in the game or with the assets and animations. However, their environment is least like the actual production environment. So the earlier we can catch issues, the lower the impact these will have on users. So the really successful studios that we've worked with that are working on this tend to do 2 or 3 things. The first thing they do is they have automated build pipelines with regression checks. They'll usually have a local device farm or library with an automation system put into it. And then some of the more advanced studios are using cloud device farms to test for basic regressions across a wide swath of devices. Now, when we talk about these automated regression checks, typically what happens is a special build or a special version of the build is developed that steps through each of the areas of concern for a game. So for example, this could automatically go through the main screen, menu screens, all the menu screens, all the different levels, just jump through them and make sure that 1, they load, doesn't crash, and 2, that they're not blowing any budgets. In fact, one of our most common pieces of feedback we get back with our GBA and SDK products is that since introducing it into their pipelines, they've been able to catch a lot of memory issues introduced by artists not optimizing their textures properly or optimizing their models properly, because it'll go through the build, it'll go through each of the stages of the game, and when it reaches where that new asset is at, the memory utilization increases past a certain budget, and we flag the build as a failure. So it's kind of nice because typically with build pipelines like Jenkins or CircleCI, the big question everybody asks is who broke the build? Who's responsible for breaking the build? Who put in code that won't compile? But now we can say, okay, who broke this performance threshold? So you can say who broke the memory budget? Who broke the FPS threshold? So typically, this will be done at the developer's desks before they check in their code. They'll just real quick run an automated check, make sure that it's safe, that we're not, oops, I may have lost my screen there. Okay, sorry. Make sure that the expected result matches their anticipation. If we add an asset that's this size, it should increase memory by X, Y, and Z. More advanced studios will typically use device farms, and we offer automated solutions for any device, really, or device setup. So we can go from the one phone sitting on a developer's desk as they're testing a feature, all the way through a cloud device farm with thousands of devices. So we have 2 solutions that help with that. GBA, which is our automation product, works great for any sort of local environment. So if you have physical control of the device, you can plug right into our GBA and it works great, collects all the data. You can pull it into your build systems to make sure that you're doing sanity and threshold checks on any game that you're developing. It's a great, great product. And then we also have our SDK, and that allows for collection from anywhere because it's actually part of the game. You install it in the game, you initialize it, and you customize it a little bit for what metrics you'd like to collect or any sort of marking out of metrics, setting up thresholds, etc. Right now, it's available for Unity. And we have an engine agnostic version coming very soon. And in fact, if you're interested in an engine agnostic version of the SDK, please go ahead and send me an email. My email is in the last slide, and I'll love to connect you to our SDK team. So this is how we typically get the data, and how we analyze it is usually through our API. We have plugins available and scripts available for most CI systems, so you can customize and make sure that you're getting the performance you expect in your development environment. So once you get out of the development phase and you've got your new feature developed, your new character has been inserted into the game. Typically, you kick this up to your QA teams, your quality assurance teams. And as I mentioned before, sometimes they're local, sometimes they're remote, sometimes it's a hybrid model where initial testing will be done with an in-house team, and then final testing will be done with a outsourced team. And again, QA tends to be a little closer to devs, so they can write more detailed bug reports, issue reports, and get instantaneous feedback almost from the devs. And since they're testing more than just does it blow a budget, they're actually playing the game, it's closer to the real environment. But at the same time, there are thousands of different devices out there. Your QA team probably won't be checking and playing the game on every single one of those devices. Then when you throw in things like differences in networks and availability of the quality of the cellular connections, you get a huge matrix that just can't quite be replicated in QA. But it's a lot closer than the device sitting on a developer's desk. And how we collect this data and how we analyze it is typically done by a few different ways. A lot of studios start out by using the manual profiling tools. So they'll start out using things like Xcode, Instruments, and Android Studio. Then we have automated metrics collection. And then at the end of the day, we also have automated metrics processing. So let's start with the manual profiling tools. So these are things that are from IDEs or engines or sometimes third-party vendors that allow you to hook into your app, monitor the performance of it. And they all have their pros and cons. Xcode Instruments, Android's Performance Profiler, Unity's Profiler are three of the ones that we see most oftenly used. And they're great. They're tools from the vendors, typically from the platforms themselves. So they know what they're doing because they've built the actual tools. The problem that we see a lot of studios run into is the data is sort of siloed. The data from Xcode Instruments is great for iOS devices, but it doesn't give you any information about Android devices. And there isn't really a nice way to see and display all of this data from Android and iOS across devices offered by any of these tools. So there are a lot of manual tools out there, or a few manual tools out there that allow you to do cross-platform manual performance profiling. GameBench Pro is our sort of flagship product in this space. It allows QA teams to monitor games in real time as part of their process. And then, of course, automated collection happens with our performance SDK, like the GameBench SDK. Because it's part of the game, you're always just collecting that information. Now, if you're doing if you're doing QA testing at a studio, you may be doing this across 40 devices, 50 devices, with several sessions, playtime sessions with these devices. How do you analyze all this data? I mean, the more devices you add, the more realistic it is. It's more representative of the environment you're working or your game will be deployed in. But it's a lot of data. And that is where automated analysis comes in. And this is something that we've built called Smartsheet. We have multiple versions of this for different spreadsheet programs. So Google Drive, Google Sheets, Excel, etc. And this is a very simple tool that allows you to set thresholds for different devices per device, tiers, and then different metrics being able to pass or fail per that device. And this is great because as soon as you've done all of your QA tests, let's say with the SDK, so your QA person doesn't even know that the performance profiling is going on. It's just happening in the background. The data is being collected and uploaded to your GameBench instance. You can use the fetch button to pull in the most recent sessions for that particular title, because you can filter by title, and you can even filter by device as well. So if you're only concerned about a subset of devices, you can do that. You can pull in the most recent sessions and have an automatic analysis already be applied, and you can see which devices fail, which builds fail, and which ones have passed. This allows you to quickly go back and say, hey, it looks like we've got a real issue with some of these Huawei devices. 3 out of the 5 managed to pass, a couple of them failed. We need to figure out what's going on here. Automated analysis is a big thing, especially as your data set gets larger and larger. So we've noticed that a lot of our clients that are using Smartsheet are really loving this because this allows them to very quickly get a real good peek into exactly how their games are performing across a large variety of devices and sessions. So your QA team comes back and says, hey, all the bugs we could find, all of the issues we could find, we've resolved them. We're almost ready to go. Most studios will typically include a beta or soft launch phase. And this could be, again, like I said before, could be geographically limited. So you're only targeting a specific country or region with your game being released. It can be an opt-in beta to, enthusiasts who are really interested in playing your particular game. And it can also just be, distributed within an organization and played on their devices. Beta phase is great because it is more reflective of that final environment. And we really recommend our studio clients to use a soft launch or beta phase to validate their performance before releasing into production. And the way they typically do that is either with or including automated metrics collection using an SDK, like the GameBench SDK, which I talked about very briefly before, which allows the data collection just to happen seamlessly in the background. That automated metrics analysis using Smartsheet allows that data to be turned into actionable items to catch any sort of edge cases that may have not been tested in the QA or dev phases. Maybe one of your beta users has an older Android device. I happen to have on my desk somewhere a Moto XT6 something or other, which is a device from 5 or 6 years ago. It's very old. I don't think it can run past Android 7. It's probably going to be an edge case that might cause issues if I'm trying to play a game. So that data, that analysis allows you to catch problems in the beta phase. We also, a lot of studios will do an independent analysis, a verification of their game. And they'll typically talk to our GameBench Labs team about this. And I'll go into that just a little bit more because we've kind of already talked about the SDK and automated metrics and the analysis. So let's look at that sort of performance discovery report or independent analysis. So a lot of studios reach out to GameBench for help with this because they want to have an unbiased opinion from real gamers that are trying to play the game to win on real devices. And typically they'll do this in a game device pair scenario. So there may be 3 or 4 or 5 devices that make up a large percentage of their user base. It could be flagship phones. It could be older iPhones. Every game, every studio has a target demographic that they're trying to ensure they have the best experience on. And most games have titles that are similar in gameplay or content that your pre-release may be competing against. So what we offer as a service is we will independently review your game on the devices you're interested in, as well as your competitors' games, because our tools don't need to necessarily be installed inside of the game or modify the game at all. You don't need root. For Android devices, you can get comprehensive metrics on any title, any competitor, and see where you stack up against them on the devices that you care about. This really is, for a lot of studios, the kind of final approval before going to production, because they want to make sure that everything that goes out is going to look great on the devices they care the most about. And finally, we've gotten to production. This is the phase that everybody loves or hates, where your game goes out into the wild and you find all sorts of fun things. Whoops. Continued monitoring of performance is critical in this phase, because this is the real deal. This is where your game is on everybody's devices. You're seeing any errors or issues that you couldn't have predicted in the earlier phases of development, QA, and soft launch. And feeding this data back to the development teams is critical. You know, other stakeholders have a view into this as well. They're interested in you know, user retention and drop off. They could be interested in load times for ads that are embedded into the game itself. But the developers are really the ones that need to have this data and see this as easily as possible. And right now, there aren't a ton of ways to get live production data from the game itself. We have a live SDK. It's in a very limited access beta. And if you're interested in deploying this into a live game, please, again, email me. My email is at the end of the slide deck. It's eli@gamebench.net. So we have a GameBench Live SDK, which is streamlined and optimized to create the smallest impact in terms of performance, because anytime you're profiling, you add a little bit of overhead. So it's streamlined and optimized for that. It's also streamlined and optimized for privacy, because that's a huge concern of any game studio. Whenever you're embedding in an external third-party product, that your users' privacy is protected. So that's where you can get hard numbers around CPU usage, memory usage, GPU usage, et cetera, back to your developers, which is very, very useful. The other thing, the other piece of data that the production phase allows for you to really get is real data and feedback from user experience, the users themselves, in the form of reviews and user experience monitoring. So I'm just going to talk a little bit more about reviews and user experience monitoring. There's a couple of ways to do this. A lot of studios, a lot of games will have a little pop-up that pops up that asks if the person is enjoying the game, or gives them a scale to rate their experience on. And if it's positive, they'll encourage them to write a review. And if it's negative, they'll encourage them to send feedback to the developers. And that's a great way to get voluntary opt-in information. However, not everybody does those prompts for reviews or for their experience. And a lot of really passionate gamers will leave a review. So we've built a tool that allows us to scrape, to compile and analyze reviews for any title on any distribution network. Right now, primarily Play Store and Apple App Store is where most of the traffic comes in. And using machine learning and artificial intelligence, we're able to analyze the reviews and find exactly what your users are experiencing in terms of negative performance issues. This is really critical, because this is getting a direct line to your users, hearing their problems, what's really bugging them. So this little screenshot is of PUBG Mobile, and we can see right away there seems to be some lag issues, which, given that PUBG is a networked game, lag is a very critical thing, which people are complaining about the servers. And then it seems like there's some crashes and some slow load times that are occurring. So the really cool thing about our review tool is that it's versioned as well. So you can tell between releases, between patches, are your patches actually addressing the issues your users are complaining about? So this is a great tool to get that feedback, parse it in a way that's actionable, that your developers, your business analysts, your business intelligence people can look at and say, hey, there seems to be a real big sticking point here. We're losing users, and this latest build has a real issue with load times. What can we do to drill down into that? And then after that release is out, did that actually fix the complaints? So just want to really quickly sum this up before we go into some questions. Monitoring performance across the entire development lifecycle is critical. It allows you to actively respond to performance issues at every step of the development cycle. The earlier you catch these issues, the lower the cost is to fix them. And especially if you catch them before the soft launch beta phase, you can ensure that your users never experience these bugs, which is the goal for, I think, everybody here when they're developing a game. Continued monitoring through the live environments with both performance metric data and user experience data allows you to really get a feel for how your game's doing out in the wild, and will allow you to kind of tailor your development for those environments. So I really encourage everybody here to look at incorporating performance monitoring throughout the lifecycle of their game development. And with that, I will leave the questions open. If you have a question, please just feel free to drop it in the question section. Okay, seems to be a quiet group today. Well, I appreciate everybody's attention and you guys for attending today. Please reach out if you have any questions about any of the topics that I was speaking on or areas for doing continuous performance monitoring. Again, my email is eli@gamebench.net. Thank you again for attending. We will send out a recording of this webinar and post it as well for everybody who's attended. And if someone was unable to make it, you can share this with them. Thanks, and I hope you enjoy the rest of your Thursday.